Shama, you are there?
Yes, sir. Am I audible?
Yes. So can we start so that now it is exactly 3 o'clock. So or we wait for one more minute and then start. You can wait for one more minute. 3, 1. You can exactly start.
Okay,
Hi,
sir.
hi. Yeah, good afternoon, everybody.
Good afternoon, Kripulani sir.
Hi,
Nice
hi,
to
all.
see you.
Yeah, nice to see you all. Yeah, nice to hear. Good.
Yeah.
Sir, can we start?
Yes. So Swapna, you are okay, doctor? Can we start? Yeah. Okay. Shama.
So, good afternoon, everyone. Welcome to ICCS online webinar series. As part of building capacity and awareness among various stakeholders, public and student community about the latest information regarding climate change, Institute for Climate Change Studies is conducting a webinar series that runs every month. So, today we all have gathered here for the second webinar of the series on the topic Relevance of Recent IPCC Reports for India by Dr. Swapna Panickal, scientist, Indian Institute of Tropical Meteorology. Before starting the lecture, I would like to introduce briefly today's keynote speaker before you all. Dr. Swapna Panickal received MSc in Oceanography and MTech in Atmospheric Sciences from Cochin University of Science and Technology. She received her PhD degree in Marine Sciences from Goa University in 2006. Later, Dr. Swapna joined Indian Institute of Tropical Meteorology as research associate and worked on the Indian Ocean monsoon couple interactions. She was selected as postdoctoral research associate at Hong Kong University of Science and Technology during 2007-2008. Dr. Swapna joined Indian Institute of Tropical Meteorology as Scientist C during 2009 and is actively involved in climate change research and Earth system modeling development at Center for Climate Change Research, IITM. Her primary research areas are climate variability and change, Earth system modeling, sea level variability and change, changes in monsoon hydrological cycle, ocean dynamics, and air-sea coupled feedbacks. During her career, she has bagged several awards, honors, and has participated in several national and international conferences. And not among that, she was a lead author of the IPCC Sixth Assessment Report. So, without wasting much time, we'll directly move on to the lecture. I request all of you, other than the speakers, to kindly turn off your video and audio. You can also watch the session live on YouTube by streaming the official YouTube channel of ICCS. Now, I kindly invite Swapna ma'am to deliver the lecture. Please, ma'am.
Swapna, are you hearing?
Yeah, good afternoon. Good afternoon. I'm trying to share my screen.
Okay.
Is the screen visible?
Yeah,
No, ma'am.
your projection, no, PPT is not seen.
It is not seen. Now is it visible?
Yes. Yeah.
So good afternoon,
Oh,
everybody.
it's gone again.
Is
it
it
is gone
gone?
again. Yeah.
Oh, okay.
Yeah. I think when you select, screen selection. Earlier everything was coming fine.
Now it is coming.
Yes, it is coming. So you can put the slide more.
Yeah, when I putting in the slide mode, actually it is going. So let me put like, is it okay?
Yeah. No.
Okay. So good afternoon, everybody, and thank you, Dr. Pai and ICCS for giving me an opportunity to present the key highlights from the IPCC report. So, like the first, the working group 1 IPC report of IPCC, which was published in August last year, and the working group 2 and working group 3 reports were published recently in March and April 2022. So today we will see like what are the key messages from the IPCC report and what are its relevance for our region. So just a brief introduction about IPCC. IPCC, it was established in 1988 jointly by the WMO, World Meteorological Organization, and UNEP, United Nations Environmental Program. So the main objective of IPCC is to have a regular assessment of climate change, because we know like scientific understanding on the climate change in enhancing, it is advancing in time, and our data volumes are also increasing, the publications are increasing. So there is a need, like we need to have a regular assessment of these whatever understanding on the climate change. So main objective is to have a regular assessment of the scientific understanding on the climate change, and also like it also is a policy relevant. It is policy relevant means that 97 governments are part of UN. So these reports, the findings from the reports are also used for framing the climate policy for the governments, and it is provided for the UNFCCC and COP, and most of the report findings from the IPCC reports are fed into these meetings, so it is also policy relevant. As I told, the IPCC has 3 working groups. So working one is the physical science basis. It basically deals like what are the changes in the climate system, what has been observed so far, why it is happening, and what it is going to project in the future. So basically it addresses the science of climate change. And the working group 2 basically looks on like what are the impacts on the different societies, sectorials, how it is climate change is impacting, and what are the adaptation policies need to be framed. So these suggestions are coming from the Working Group 2 report, and Working Group 3 report deals with the mitigation. So climate change is going to happen. So what can we do for that? How can we reduce these changes reduce these impacts or greenhouse gas emissions? So mitigation aspects are mostly dealt with the Working Group 3 report. As told before, I am a lead author for the Working Group 1 report, which deals with the physical science basis. So basically, in my talk, I will be mostly talking about the scientific basis of climate change that is based on the Working Group 1 report and what is its relevance for our region. So this is the author team, like every country, like 234 authors are there from 65 countries, and it has undergone various review processes, which is just shown in a schematic like this. So once the IPCC, in every IPCC cycle generally happens in 5 to 6 year period. The first IPCC report was in 1990, and the latest, that is the AR6, sixth assessment report, which was published first. Working Group 1 report was published last year. So generally when the IPCC report selection, there will be selection process. So the nomination will be called by the IPCC to the different governments. So the governments nominate the experts, and based on that, IPCC select the authors. Once authors are selected, they will be assigned based on the expertise to different chapters. So these authors frame the chapter content. What are the things to be discussed under different topics in each chapter? So that is the way like report starts. So there will be lead author meetings, like generally we had a 4 lead author meetings at different places where we sit together and we discuss like what are the climate information we have right now and how the chapter has to be framed. So we prepare a first draft. It will be sent for a review. There will be an expert as well as the government review. Then we take the comments from the experts and we further work on the chapter. Like that, there are various stages of review process that has undergone. And finally, the report is ready. It will be first sent to the governments. 197 governments are part of the UN, so it will be sent to all the governments, and we take the consensus from all the governments on the each and every topic that is discussed in the report, and finally it is published for the public. So this is the process of making the IPCC report. As we come to the Working Group 1 report, which was published August last year, so it basically has 12 chapters, and there is an atlas also. So the first 3 chapters, it's a global chapter, basically deals with what are the observed changes in the climate system, global changes that has been happening, and what is going to happen in the future. And the later chapter, like it is more of processes, understanding the processes behind the climate change. So we have seen like these are the changes that is happening in the system or that they are projected to happen in the future. So what causes these? More process-oriented analysis is addressed in chapter 5 to 8. And this like AR6 or sixth assessment report, one of the novelties is that there is more regional focus. Like whole globe is divided into 11 regions, which includes like Asia, Africa, South and Central America, Australia, and they're also emphasized on the oceans, polar regions, Himalayas. Like that, there are 11 regions, and there are this assessment is also done especially for the different 11 regions and sub-regions of the globe. So there is more focus on the regional aspects so that it can be used for the climate change impact assessment studies and framing the adaptation and decision making for the regional scale. So last three chapters are mostly focusing on the regional aspects of climate change. And there is also an interactive atlas. So if we see from the key highlights from the report, it shows that the changes, we know like global has been warming, but the changes in the climate system are widespread, rapid, intensifying and unprecedented thousands of years. It means that if we see like the increase, we know like the increase in the greenhouse gas concentrations, they are producing the warming in the climate system. And if you see the CO2 concentrations, presently like June 2022, the CO2 concentrations are 420 ppm. And over the pre-industrial period, it was like 280. So there's a large increase has been happened. So there is these CO2 concentrations are highest in the human history. Like it is unprecedented for 2 million years. And we are also seeing its consequences. Like there is a rapid or faster rise in the sea level. And in the recent IPCC report, it is showing that Indian Ocean sea level is rising faster than the global oceans. Similarly, there are other consequences like there is a depletion of the ice, there is melting of sea ice, glaciers are retreating. So these all changes are happening, and most of the changes like they are irreversible. That means that once they are happening, we cannot trace it back. So most of them are affecting not only the human society, they are also affecting the marine ecosystem, terrestrial ecosystem, and most of these changes are irreversible for centuries to come. So climate, we know like it is a global phenomena. Climate is changing everywhere. It is changing every region on the earth in multiple ways. But if we see the regionally, like regional dynamics also plays an important role. Like for our region like India, how the circulation is changing, what is the regional pattern of warming, or how the dynamics. So all these are changing. So though the climate change is affecting globally, there are regional differences, but every region on the earth is projected to warm further, and it is projected to experience further warming. Like we know, like Paris Agreement, the main objective is to limit the warming well below 2 degrees centigrade with respect to the pre-industrial levels, or by 1.5 degrees centigrade. So the IPCC reports projects that 1.5 degree warming, we will be reaching that 1.5 degree warming with respect to the pre-industrial period, that is 1815, next 20 years. So what will happen at 1.5 degree warming? Right now we have crossed 1 degree, right? Roughly 1.1 degree warming with respect to 1850. So 1.1 degree warming to 1.5 degree warming. The report suggests that at 1.5 degree warming, the heat extremes are going to increase, and there will be long warm seasons, there will be short cold seasons. Similarly, when we go from a 1.5 degree warming to a 2 degree and half a degree warming, the heat extremes are often may cross the threshold tolerance level for both health and agriculture. So these are some of the things that IPCC AR6 report highlights based on the projected warming. And if we quickly look at the historical warming, what has been happening in the past. So this is the global mean temperature curve. This is for the northern hemisphere, and this is for the past 2000 years. And if we see like temperature were like, this is the with respect to the present day, how much this changes happen. So we see like temperatures were fluctuation, they were fluctuating, but it were lower, like it was less than 0.5 degrees or less than 0.2 degrees in the last many thousands of years. But if you see in the recent years after the industrial revolution, like 1800 or 1850, we see a large increase in the temperatures. So we can say it is compared to hockey stick, like there's a large increase that is happening over a shorter period of time. So that is producing these changes. Like we are finding like extremes are increasing, warm seasons are increasing. So this large mean temperature increase has larger consequences globally as well as regionally. But if you look in the past, like paleo scales and all, we can see like such temperature fluctuations were there before also. Like million years before, to 50 million years, temperatures was like more than 5 degrees, and there were periods like they were more than 2 degree colder than the present. But these were all happening over a larger period of time, like because of the changes in the Earth's orbital parameters, these changes were happening. But they were occurring over a longer period of very longer, slower time scale, a longer period of time. But what we experience presently is that large increase that is happening over a shorter period of time. And this is exactly what we see from the CO2 concentrations. Like this is the data for the last 800,000 years. And the CO2 levels were like 240 ppm. And I think 1850, it is like 280 ppm. But we see right now, like June 2022, the CO2 concentrations are like 420 ppm. So we are seeing a large increase. Like this is exactly reflected in the temperature curve also. So we see like CO2s are increasing, that well-mixed greenhouse gas concentrations has been increasing. So they are trapping more heat in the climate system and they are warming. As a result, we see increase in the mean temperatures. Not only the mean temperatures are increasing, the extremes are also increasing. Kerala experienced the severe flood in 2018. There are many incidents, and we like this 2022. It was a very India witnessed the heat wave conditions. It's just an example I am telling. Like these are some examples. Like extremes are increasing, or they are going to increase. Like ICCS report also recently they are showing like there is the Kerala also witnessed average maximum temperatures are on more than 1.67 degrees per 100 years. So these are certain references what we are happening, like extreme events along with the increase in the mean, extremes are also increasing. So what is causing this? So we need to know like why this is happening. For this, we do the climate model simulations to try to understand the processes, what is causing this. So we force the climate models with only the changes in the orbital parameters, natural forcings like volcanoes. When they burn, they eject a lot of aerosols into the atmosphere. So they can cut down the solar radiation. They can temporarily cool the Earth's surface. So these are the certain changes or the Earth's orbital parameters. So these are the natural processes. They can affect the changes in the temperatures. Also, there are like man-made or anthropogenic processes like CO2 increase, land cover changes, or the increase in the aerosol concentrations. These all are the human or induced what we are producing it. So the black curve is the observed increase in the temperature. So roughly 1.1 degree warming we can see with respect to the pre-industrial period. And the blue-green curve is that only caused by the natural. So we can clearly see that the natural processes cannot explain the observed increase in the warming. So it is all caused by the human influence or anthropogenic contributions are dominating the observed increase in the global mean temperatures. And IPCC report also looked at the different contributions. How much is there coming from the different human-induced contributions? Like we have a 1.1 degree observed warming. So the well-mixed greenhouse gas concentrations produces roughly 1.5 degree warming. And it is slightly offsetted by the aerosols. They are slightly cooling. So altogether, when we see like when the observed warming is totally balanced by the anthropogenic contributions. So this whatever is happening in the recent years, that is caused by the human activities. So now we have seen like there is a warming in the climate system. So how we look at the future? What will happen to the future? For this scenarios, the IPCC report and CMIP 6, like there is a couple model index comparison project in which the different modeling centers worldwide, they have their own model setups. So they will use a common forcings to run their own climate models. And because the forcings are the same, we will get a multiple ensemble and multiple models. And based on that, we can come into an understanding of the climate system. What is going to happen in the future, what is going to project in the future. So for this, IPCC uses 5 set of illustrative scenarios. They are called illustrative scenarios because it also depends, they are called the socio-economic conditions, because what we are going to, how much greenhouse gases we are going to eject in the future will also depend upon what will be our development strategies, what is our social or economic conditions, political conditions. Those all matters, like how much greenhouse gases we are going to emit in the future. So based on that, five illustrative scenarios has been identified. It includes a very high emission scenario in which the CO2 level or greenhouse gas concentrations currently double by the mid of the century, and high scenario where it will double by the end of the century. And if we follow the same pathways what we are emitting right now, that is the intermediate scenario, and there are low scenarios in which we will be like becoming net zero. That means there is a stabilization, how much we are emitting and how much the climate system is taking in. So there is a stabilization. So there will be net zero emissions by 2050, followed by negative emissions. So based on these five set of standard scenarios, the projected changes in the climate system for the future up to 2100 and 2300 has been formulated. So this is an example, like based on these scenarios, how the individual well-means greenhouse gases are going to change. Like CO2, right now there is a 40 gigatons per year emissions that is happening. If we follow the very high emission scenario, we will be emitting like a 120 ppm per year by the end of the century. And presently what we are following, that it will be like 40 ppm and it will be gradually decreasing. So these are the different scenarios they have used to frame the scenarios. Well, if you see the projected changes of warming that is projected for the future, and this is the globe. This curve is the global averaged temperatures starting from the 1850 to the 90. Presently, it is starting from 1850 and up to the end of the century, 2100. So if you clearly see this graph, we can see that the temperature is projected to increase. Whatever we told, like there are five scenarios, low emission to very high emission scenarios. So whichever scenario we are following, the temperature is projected to increase at least the mid of the century in all the scenarios. That is how the IPCC report is projecting that we will be reaching a 1.5 degree warming by the another 20 years, because CO2 is a well-mixed gas. It is having a long residence time. So once it is emitted in the atmosphere, it can stay there unless it has to be taken by the oceans and we get the stabilization. This is going to warm the climate system. So we, by like low emission scenario, SSP 119 still itself, we will be having a 1.5 degree warming by the next 20 years. And if we follow the present day emissions, we will have a 2 degree warming by next mid of the century. And if we follow very high emission scenario, we will be reaching more than 4 degree warming by the end of the century. So 1.5 degree warming to a 2 degree warming, we are seeing like there is a lot of changes. Extremes are projected to increase, and that will be adversible for many sectorial, that will have many sectorial impacts. So these are the things that we need to consider when we look at the regional projections. So let us see little more details, like, because it gives a global picture, like how was the warming in the past and what is going to project in the future. So what is the relevance for our region? So this is the spatial map, which is showing the temperature change, what is happening right now. That is roughly about 1 degree global warming. And if we go from a half a degree additional warming, 1.5 degree, 2 degree, and 4 degree of global warming. So this is with respect to the pre-industrial 1850 period. So with respect to 1850 period, presently we are about a 1 degree global warming. So if you go from a 1.5 to 4 degree warming, how the globe is going to change. So this spatial map clearly shows that as the global temperatures are increasing, regional patterns are very different. Like we clearly see a land sea contrast. Land gets warmer than the oceans, and the polar regions are warming, especially the Arctic region. It is warming, ice-covered regions. They are warming higher than the other region. And if we see for our Indian region, like there is more temperature is projected to increase over the north and northwest India than the other regions. But still we see like a 2 degree warming for the present scenario. We see like the global mean warming is 2 degree. We also expect like roughly like 1.5 to 2 degree warming that we can expect in the next 20 years or next 30 years. That is what is projected for the India. This is for the mean, and this shows how the extreme temperatures are changed in the future. And SAS is the South Asian region. As I told, the report also has more regional focus. So the globe is divided into 11 regions, and these 11 regions are again divided into 60 sub-regions. So South Asian region is one of the sub-regions where the assessment of the certain indicators has been made specially for these sub-regions. So SAS is a South Asian region, and 3 dots, that signifies that whatever changes are of high confidence. High confidence means IPCC, when we make the assessment, it should not be based on our own assessment. We look at the literature, like if there is a temperature change that is happening, how many studies are supporting these changes, and what are the data sets new, because we have used more simulations and whatever literatures are there. So how many models are agreeing to this? So based on all this, if there are high confidence means there are based on all this, all of them are agreeing, we can provide a high confidence to the changes. For if we see for the South Asian region, the hot extremes have already increased. That is shown by the 3 dots with high confidence. And the report also shows that with every additional half-degree warming, these extremes, extreme heat extremes, are projected to increase over the South Asian region. And if you look at the precipitation, like this is the pattern of precipitation: 1.5 degree global warming, 2 degree and 4 degree warming. As we see, like we go towards the higher warming levels because the moisture holding capacity also increases with warming. So there is more warming, like at 1 degree warming, the moisture increase by 7%. So there's an exponential increase in the moisture. But also the dynamics also matters, like how the circulation is going to change. All this matters for the precipitation changes. Still, what we see is that if we go to the higher warming levels, the precipitation, this is for the annual precipitation, but for the summer monsoon, June to September rainfall also, the report shows that the summer monsoon precipitation is also projected to enhance by the end of the century. But we have seen that the Indian region rainfall has been declining for the second half of the 20th century, so mid of the 20th century. And the IPCC report shows that this decline in the precipitation was mostly attributed by the aerosols, increasing the aerosol concentrations. So that is what has caused the decline in the precipitation during the mid of the later 20th century. But our Indian region, the precipitation, annual and South Asian summer monsoon precipitation is projected to amplify with warming. It is all applicable for the other monsoon regions also. However, along with the increase in the precipitation, the modes of variability like ENSOs are also projected to amplify. The frequency and intensity is also projected to intensify. Similarly, the Indian Ocean dipole events are also projected to amplify. So these modes also interact. So like there will be like interannual variability, there will be a lot of interannual variability. There will be years with excess monsoon and there will be years with the deficit monsoon. So there is going to be an increase in the summer monsoon precipitation over India, but there will be also more interannual variability in the rainfall. And as I told, like when the temperature, the moisture holding capacity increases with warming, so it also increases the precipitation extremes. So we are experiencing, like there are many events, extreme precipitation or heavy precipitation events which we are witnessing recently. So these events will be projected to increase, like a rare event, once in 10-year event or 1 year, 20-year event that is happening presently once. So that will be like double or triple by the higher levels of warming. And also for the extreme precipitation or heavy precipitation events, it also depends on the regional dynamics, how the regional patterns of warming, whether that region has a higher levels of warming compared to the other, or the circulation or dynamics. So these all matters when we have to really look into the changes in the extreme precipitation or a regional perspective. So over the South Asian region, the IPCC report shows that heat extremes have been increased, and the summer monsoon precipitation that has declined in the recent past will revive, and there will be more excess precipitation, enhanced precipitation activity by the end of the century. And over our high mountain regions, like Asian high mountain regions, there will be snowfall, there will be decline in that, and there will be glacial retreat. And report also shows that there will be projected heavy precipitation events can also happen over the high mountain regions of Asian region. So this actually, there is a regional assessment. So more details are also provided in the report about this. If we look little more deep, like we have seen the temperature change, how the regional precipitation or the extreme heat waves are going to change. So let us see little more details on the changes in the ocean, how the ocean is going to change, especially the Indian Ocean or Arabian Sea, how it is going to change. So as we know, like if there is a perfect balance between the incoming radiation and the outgoing radiation, we'll have a pleasant climate or pleasant earth system. But because there are more greenhouse gases that are being emitted and they are trapping more infrared radiation, so they are warming the climate system. So where is this heat going? So most studies shows that most of the heat is taken by the oceans. More than 90% of the heat is taken, absorbed by the oceans. This is because ocean is having a huge heat capacity. Heat capacity is much higher compared to the land and other components, and also it is having a huge mass, and it has an effective current systems, like there's a conveyor belt that we have. The equatorial regions receive more solar radiation, so there will be more warming. So these currents transport the warm waters to the polar regions. As they reach the polar regions, they become colder and they become denser, so they sink and they flow down southwards. And this conveyor belt, they carry the heat throughout the globe, and it disconnects all the global oceans. So, but it is a very slow process. It takes over 1,000 years of time to stabilize. But most of the heat, because of the huge heat capacity of the oceans, most of the heat is taken by the oceans. As a result, like there is, when the heat is going into the oceans, it will expand. So there's an increase in the heat content. So right side panel shows the heat content, that is integrated temperature. If we are integrating over the upper 700 meters, so we can clearly see, because we have a lot of information, subsurface ocean informations are available since 1950s. Prior to that, we have information, only reconstructed sea surface temperatures were available. Subsurface ocean informations have come up after 1950s. So if you see like 1950 to the recent years, so this shows that heat content has been increasing. This is especially seen like after 1990s and 2000, we clearly see an increase in the ocean heat content. And that too, this heat is trapped in the few hundred meters. So like 700 meter or up a few 500 meters, this most of the heat is trapped. Because more heat is trapped in the ocean in the upper layers, so there is more heat, water will expand. So water expands, so it will be produce the rise in the sea level. So this is the global mean increase in the sea level. So if you see for the longer period, like sea level, it was reported global mean sea level, it is like 1.8 millimeter per year is the rise during 1960. But recently we have the satellite data, like altimeter data, it gives a global coverage, and the data is available from 1993 onwards, and all the global oceans have been homogeneously covered. The satellite data shows that the global sea level rise is increasing. Like recently, WMO report also shows that there is a larger, faster rate of accelerated sea level rise in the global oceans. Like if you see for the global and Indian Ocean, WMO in the last 10 years, sea level in the Indian Ocean is rising at a rate of 4.5 millimeter per year, whereas in the global ocean, it is like 3.6 millimeter per year. So there is a global acceleration of sea level rise. But Indian Ocean, the sea level rise is accelerating more than the global. So just I will show, this is the spatial pattern of sea level rise in the Indian Ocean. So we can see like it is not homogeneous. There are regions like higher rise and there are regions of lowering of the sea level. We have the tide gauge data that are available from along our west and east coast of India. Like Mumbai, we have data from 1880 onwards. Cochin, we have data from 1930. Like Chennai, we have data from 1950 onwards. So long time, see this data has been available along our coastline. So if you see this observed data sets, they shows that there is an acceleration of the sea level, or sea level is rising along our coastline, along the west coast and east coast of India. And why the sea level is accelerating in the Indian Ocean? It is just because of the geography of our region, because Indian Ocean is landlocked to the north. So whatever heat that is trapped in the ocean, it is not being transported like Atlantic or Pacific. It can transport up to the northern regions, and there are circulation systems that carry the heat till the northern polar regions. But in our region, ours is a tropical basin. It is landlocked to the north, so whatever heat is there, that is trapped within the system, and we have a very shallow overturning circulation. So because of these features, Indian Ocean is having a higher, fastest rate of sea level than compared to the global oceans. So this is the mean sea level trend concern, which again shows that sea level is accelerating in the North Indian Ocean, Arabian Sea, Bay of Bengal, and some regions like Western Pacific, that there are, according to the PV or El Niño, these changes happens. But Indian Ocean, mostly there is a larger rate of rise. And the right side bar graph again shows that Indian Ocean, this is, I have not updated, it is showing 3.51, but recently, like last 10 years, if you can see, it is more than 4.5 millimeter per year. That is the sea level rise if you consider for the whole Indian Ocean, 30 degrees south to 25 degrees north. So there is an accelerated sea level rise, and it can be caused by many changes. Like basically what we have seen, it is due to the thermal expansion. So there's a more volume is increasing. So volume increases, sea level rises. But in other regions like the subsidence also can happen, like the Diamond Harbour in the Bay of Bengal, where the sea level rise is about more than 5 millimeter per year. It is because the land is subsiding. So subsidence also produces these changes. But mostly like if you see for the Indian Ocean, especially in the North Arabian Sea or Bay of Bengal, North Indian Ocean, it is mostly more than 75% is coming from the thermal expansion. And this was one of our study wherein we looked at the changes in the sea level, and what we have seen that the monsoon circulation has been weakened in the later half, like 1950, we see a weakening of the circulation. So like Indian Ocean, as I told, it is landlocked to the north, heat is not transported to the north. So whatever we have a shallow overturning circulation. So when we have a southwesterly monsoon winds, there will be a net transport. They transport the heat from the north Indian Ocean to the south. So this is on an annual basis, like May to October. This is the transport, and other season it is the reverse. But it is dominated because summer monsoon winds dominate the Indian Ocean circulation. So it is dominated by the summer monsoon winds. So when the monsoon winds has weakened, more heat is getting retained in the North Indian Ocean. That is producing more sea level rise in the North Indian Ocean. And if we look at the trends in the sea level in the Indian Ocean, like we see from the west and east coast of India, both the regions shows like the sea level is rising. For example, like Cochin, the sea level rises roughly like 2.5 millimeter per year. And if you go to the north, Mumbai, the sea level is more than 3.3 millimeter per year. That is from the satellite estimate. Similarly, the east coast of India also, sea level is rising, but there are regional differences we have to see. And if you look for the projections, if you see the upper right panel, it is the SSB 585 median range projection. So what it shows that sea level is projected to increase, and Indian Ocean, especially the North Indian Ocean, Arabian Sea level is projected to increase more than the other regions. That means that there will be more increase because more heat is getting trapped and regional features are different. So there is more sea level is projected to increase in the Arabian Sea in the coming decades. And if you see the global mean projections, like sea level is projected, whatever may be the greenhouse gas emission pathways, because sea level rise is an irreversible process. There is heat that has been taken up by the oceans. So this heat is going into the ocean. So that will produce the thermal expansion. So that sea level is projected to increase. And if we go with a very high emission scenario, global mean will be like one degree, it can rise. And what is for our coastline? This is an example like what is seen. So this is basically we looked at all the CMIP 6 models, and we have the tide gauge data along our coastlines. So we correlate like how much is the observed changes in the sea level along these tide gauge locations, and then we looked at the CMIP 6 models, how they are projected to increase. So this is for the 2050 and 2100. So we can say like the Mumbai at presently like by 2050 like sea level is about 0.17 meters, that is relative to 1995 to 2040. So 0.17 meters it is projected to increase, and Cochin it is like more than roughly 2 meters. If you go to the further warming, like we see Arabian Sea is projected to warm more, or Arabian Sea level rise is more. So we can expect like west coast of India will have higher sea level rise than along the east coast. So Mumbai has will have a 0.46 meter rise in the sea level, whereas Cochin will have more 0.5. So there will be regional differences in the sea level rise also. And as I told, Indian Ocean, because of the peculiar geographic features, SST sea surface temperature is warming, and the AR6 report clearly shows that faster warming rate is observed in the Indian Ocean than the other global oceans. So SSTs are warming more. So we also see like because SSTs are warming, mean sea level is rising. And because of this, like AR6 report doesn't talk more confident over the tropical cyclone changes in our regions in terms of its frequency or intensity, but it shows that with further warming, like our own study shows that with further warming, like SSTs are getting warmer, so the conditions are thermodynamically favorable for intensification of the cyclones. So cyclone intensity can increase in the future. So there will be mean sea level rise, and cyclones are increasing. So cyclones increases, they produces the surges, storm surges. So there will be like we have seen like Cochin or Mumbai, it will be 0.2 meters of sea level is going to happen. But 0.2 meter, it is the mean sea level. Along with that, if the cyclones are also increasing, they also produces huge surges. So extreme events, like what we have seen in the atmosphere, like extreme heat wave conditions are going to increase. Similarly, the extreme sea level events are also projected to increase for our region, Indian Ocean region. This is just an example. Like last year, 2021, we had got two severe cyclonic storms, Tote and Yas. Yas was very severe, and Tote was an extremely severe cyclonic storm. So Tote, it followed along our coastline, and the all the stars that are shown along our coastlines are the high water levels. This is based on our tide gauge observations from inquiries, and they shows that all of them along our coastline, it was producing high water levels, and it like Mumbai and all were higher sea level. Similarly for the Yas also, it was a very severe, but Taute was an extremely severe cyclonic storm, but the high water level was higher with Yas than with the extremely severe. So that also depends on the topography, regional enclosed basin, all those things also matter. So it all depends, like there will be mean sea level, and if the cyclones are intensifying, they can produce the extreme events. And the down graph is about the Mumbai. As I told, we have long observations, 1880 onwards, we have the data available. So we have to look at to estimate the extreme sea level, we need to look daily changes. How much is the sea level? We gathered hourly sea level data from 1880, and we looked like the first 60 years and the later 60 years, how the extreme sea level has been changed. So first 60 years shows a blue curve, and the red curve is for the last. So we see the tail is changing. No, extreme sea level events are increasing in the recent years. This is based on a long data what is available along the Mumbai coastline. So these are studies like which also look from the model projections, like how the extreme sea level events are projected to increase. And this is based on our data, tide gauge data. It again shows like when these are the intensity and duration of the extreme events in the past till 2020, what is observed. Again, like west coast of India, it shows like mean sea level is also increasing. Along with that, we see more increase in the extreme sea level events in the west coast than over the east coast. Because Bay of Bengal, we have like this next curve. This clearly, this is for the Cochin, and downfall is for the Chennai. Chennai is Bay of Bengal. We have the cyclones happening it has a frequency of cyclones are more in the Bay of Bengal. So we get episodic rise in the sea level or the surges. But along the west coast of India, Arabian Sea is warming at a higher rate. The mean sea level is increasing. So what it is seeing that the Cochin, the extreme sea level rise is much higher than the Chennai. So that is even projected for the future. If you look for the future also, like the very rare events, 1 in 100 years events that can occur annually, that is with the extreme scenario I'm talking about, they can occur annually by the end of the century or by the 2050 at Kochi than other east coast of India. So there are regional differences, but both mean and the extreme sea level are projected to increase along the coastlines. And these are other impacts like heat waves. Recent many studies are coming up, like marine heat waves are increasing, and the fisheries, because ocean are warming more, tropical regions are warming more. They try to migrate and they migrate former there will be migration of the fisheries. So there are other systems, not only on the human, but there will be affecting on the marine ecosystem. All this will be coral mortality. All these things can happen with the increase in the temperature in the oceans. So if you go back to the atlas IPCC, I told that's an interactive atlas. So we have the regional information. Globe is divided into 11 regions, and we can see like each of the 11 regions, what are the projected changes, like how much is the temperature going to increase, how is the precipitation, or there are climate impact drivers, like they are the physical changes in the climate system that have sectorial impacts. All these informations are available. If you want to know more about that, you can go into that and you can see like what is projected for our region. And this is just a snapshot, like with the 2-degree warming, how much will be the warming seen for this. And you can see different grids. So this globe is divided into different grids, and we can zoom into that particular region and we can see like how much is the change that is projected in the future, or with levels of warming, how it is going to change over our region. And so IPCC report tells that these are the different impact drivers. So all the blue bars, they shows that there is a high confidence that they are going to increase. Up are all increase, and down orange ones are all decreases. So this high confidence is shown like there will be an increase in the extreme heat events. the mean precipitation is projected to increase, mean sea level is projected to increase, and there are changes that they are also going to decrease, like cold spells are going to decrease, frost is going to decrease. So these are also given. Climate impact drivers of the world are also provided in the IPCC report. So certain changes we can expect, there will be high confidence that they will be increasing, and there are other changes they will be decreasing, that also is provided. So as IITM, we have our own contribution to IPCC report. Like IITM, we have the IITM Earth System model. So this has participated for the CMIP coupled model intercomparison project, and this model outputs have been utilized for as one of the model from among the other global models for assessing the changes in the climate system. So these are the experiments that we have provided. We have performed with the IITM Earth System model, and all these data set we have in Earth System grid located at CCCR IITM. So the data can be downloaded freely and it is available for public. So these data sets are also used for the preparation of the IPCC report. So that's all. So only thing like IPCC report suggests is that to limit warming, we need to have a sustained reduction in the greenhouse emissions are necessary. So that is not only reduce the impact of consequence of climate change, but that also will help to improve the air quality and our health. Thank you.
Thank you, ma'am. It was an excellent and thought-provoking lecture. I would now request the participants to engage with Dr. Swapna if they have any queries.
Yeah, Swapna.
Yes.
I myself will start with question before others, ask question. So it was an excellent lecture actually. So you gave brief about how IPCC report is being prepared. So this is very important because many of our audience are students actually. So they have they by now they may be knowing how the IPCC prepares this vast report and what are the how much time it takes. It's a time consuming and it's a long process of review, etc. And you also have given how important for India, and also particularly you have given for Kerala as far as level. So my before I go to what are other relevance to Kerala, I also want to just from you that the students since there are many students, can you give a brief if students want to analyze this CMIP 6 models, how they can work and if they want to prepare a climate change projections or make it locally, what are the important now they should concentrate and how they can do that?
Actually, if we see this Atlas is a big tool to start with. So they can visually see like what are the changes that is going to happen, especially our region, Bay of Bengal, Arabian Sea. What are the changes? It has a focus on the oceans also and all the land portions. So first they can start with the Atlas and they can look into that. And there is also, especially for the tool, like for the sea level, there is a NASA, there is a sea level tool. They can just Google it, NASA sea level tool. They will get to know. So this IPCC data that has been used is already provided. Like they can look at the maps and they can see like it is with respect to 1995 to 2014. That is the base period used. So how much is the sea level is projected to increase along different coastal locations. So that they can look in and they can get the data and they can do their own analysis. That is one way. And or else if they want to look get into the CMIP 6 data, they should SPF site. So they will get a unique login and password. From there, they can go into the ESGF server and they can download whichever data they wanted to do, and they can do their own research based on the CMIP 6 data sets. So these are different ways. Like best ways to start is to look into the Atlas.
Yeah. See, already IITM is providing that Cordex data of CMI 5
Yes.
actually, CMIP 5 data. So that is readily available. So when are there any plan for Cordex type similar to Cordex for CMIP 6? And if it is that, when is likely to be available? Downscaling.
Downscaling, actually there are models already available. Like Codex, we have done it with the CIMIP 5 data. We have used the CIMIP 5 data, and that is how the Codex simulations has been done. And there is another project of Codex Core. That there will be using the CIMIP 6 data to downscale the project for our region. Presently, IITM is participating only in the third pole experiment, wherein they are looking at the Tibetan regions, what are the changes going to occur. That is also a flagship study of the Codex. So right now, IITM is participating in that flagship study. So based on the availability of the resources and manpower, we will be planning like what will be our next stage for the Codex, whether to download the CIMIP 6 data, or because we also have a plan like we have an IITM ESM. Presently, it has done at a 60-62, roughly 2 kilometers. That is what we have used for our CIMIP 6. Same version of the AGCM is being run at IITM ESM at 25 kilometers. So that data will be very much useful for the regional assessment. So that historical simulations we have already carried out, and presently we are working on the projections. So it is like a global model AGCM with a 25 kilometers. So that will be our contributions to the Codex, next stage of Codex. So that data will be provided. So that will give more regional changes. We can access more regional impact assessment can be done based on that high resolution IITM ESM AGCM trends.
Yeah. So till that 0.25 data is likely to be available, maybe it may take 1 year or so. So whether people can go for a statistical downscaling, or you feel,
if you really wanted to look into the statistical downscaling, data is already available. Either you can start with your own center can do the statistical downscaling, or the 25 kilometer runs, what we are doing right now, that will also eventually will be available for this one. So I think that is possible. Like it can be used for the regional assessment. That is also possible.
Great. And for Kerala, so you have mentioned about sea level rise, which is a very important aspect. Particularly in recent years, we get some cyclone, in the Arabian Sea, etc. What are the other factors that you see that Kerala has to be careful, with the climate change?
Kerala has to be careful because we have the Western Ghats. Our extreme precipitation events are projected to increase. So, and we are also seeing like there are a lot of landslides are happening. I am not telling like it is just because of the climate change. There are other factors also, but these type of events, like all the extremes, not only like the rainfall, the sea level, but the extreme rainfall is going to increase. So that is one of the aspects we really carefully have to, because Indian Ocean is warming, there will be more moisture and the dynamics are going to change. So extreme rainfall events are definitely going to increase. Similarly, like other risks, so associated risk also like landslides and all those things has to be looked in more detail, like our especially for the particular regions. And then only we can come, because IPCC report gives a global and there are certain specific regions that has been assessed. But if we have also a climate change assessment report for India that also produced by MOS and CCCR. That also gives little more information about the Indian region, how the climate has in the past has changed and what. But especially for Kerala and all, I think we need to have a little more focused assessment on the regional aspects.
Yeah. Similarly, you had shown climate projection for winter and monsoon. So there is a large difference. I think that winter, particularly, there is a decreasing trend. Am I correct, actually?
We are talking about precipitation?
Yes, I'm talking about precipitation.
Yeah. What I have shown the figure is about the annual mean precipitation, that is for the globe. So annual mean precipitation and also the summer monsoon precipitation, like chapter global water cycle changes, chapter 8, they looked into the water cycle changes and they have a specific assessment for the South Asian region. So what they are showing is that South Asian monsoon precipitation is going to enhance with warming. That is the assessment from the IPCC report.
During DJF,
winter, I think, yeah, we because we need to give a confidence, means all the models should agree. Then only we can provide a much confidence on these changes, because precipitation, especially like it is very difficult, like models agree on this aspect. So I think winter monsoon, we are not getting much agreement among the models, but South Asian monsoon, yes, we can see like warming, it is projected to increase over our region.
Thank you. So you can ask, anybody else has got questions, so they can actually.
I have shared my email ID also. If anybody has any doubts, they can contact me also. I can reply to that.
Yeah, you can put in chat box actually. So we will also provide, and you can have this PPT. If you can provide, we will put in the website.
Sir, may I ask a question, please?
Yeah. Please, Mohan.
Thank you, Paisar, and thank you, presenter. It's very nicely presented, and it covers. It's the topic is just mentioned India, but it covers whole South Asia, I should say, and especially regarding the ocean observation points and climate change scenarios. So, what kind of data you have used, and what are the points? Maybe one slide you have mentioned some points name. So these are the historical some data, and with the projection, something like that.
Most of the sea level changes, what I have shown, that is some of the projections are from the IPCC report. So some of the maps, what I have shown, like the extreme sea level changes and the mean sea level, that is done from our own center, our own analysis. We have used the tide gauge data, like we have the tide gauge data from along our coastlines that is maintained by the Survey of India, and also recently INCOIS, after 2010, INCOIS is maintaining this tide gauge data. So we have got the data from these tide gauges. So based on our analysis, what all figures I have shown, that is based on the tide gauge data, and also we have also used the satellite data, IVSO satellite data since 1993.
Okay, thank you. Yeah, that's all. Thank you very much.
Yeah. Anybody else? Any other questions? Dr. Rao, you want to have any questions?
Good afternoon, sir.
Yeah.
Right. Good afternoon, madam. It was a very nice presentation. I just had a small doubt. Your presentation was very nice. In that presentation, I just saw one point. You are talking about the landfall of the increase in the number of cyclones, and the landfall is also increasing. Therefore, but the landfall is only a short-term phenomenon. In what way it is connected to the rise in the mean sea level?
No, I am not talking about the increase in the cyclones. We only talk like the intensity of the cyclones are increasing, because
even that also.
Yeah. So when the cyclone intensities are increasing, because when the cyclones passes, they produces the surges, storm surges. So these surges, when we have a background rise in the sea level, so sea level is already elevated, and on the top of that, these surges, because intense cyclones produces more severe surges. So both of them are interacting together, and we have the certain, like Mumbai and all, we have very high tide. The tides are there, so waves are there. We assume that tides and waves are not changing on a long term, but the changes in the mean sea level and the surges, that will produce the extreme sea level events. So like intensity of the cyclones are increasing, they produces a higher surges, and there is on the background there is a mean sea level. So that's how the extreme sea level events can increase.
No. My point is, the surge will increase because of the mean sea level high rise.
No,
right?
No. Surge will increase depending upon how the local factors, like how much is the pressure difference, or it is like mostly driven by the meteorological factors based on the cyclone's intensity. So that will not depend upon the mean sea level. It is like a weather phenomena, like cyclones are happening. How much is the pressure difference? What is
that's fine.
Yeah.
My point is, how does the surge will cause increase in the mean sea level rise?
Because these are non-linearly interacting. Because there is a mean sea level, and surge is also there as part of the sea level, right? So their interaction is not linear. It's a non-linear interaction. Because of the non-linear interactions of the mean and the surges, that is producing the extremes.
Okay, fine. Thank you.
Any other question?
Good afternoon, ma'am. It was a really nice presentation. I had a doubt regarding the regional climate change analysis. Usually, in your presentation, I was observing that in the future we are projected to have more climate extremes, whether it is precipitation or temperatures. So,
yeah, because IPCC report, what it is telling, that if every additional half a degree warming, the extremes are projected to increase. So if we have a more warming over a particular region, that means that with warming, moisture also increases. There will be more evaporation, the more moisture holding capacity in the atmosphere increases. So when the warming increases, extreme precipitation events can increase. Similarly, heat extremes are definitely going to increase.
Okay. So my doubt was that usually in the regional, when from a hydrologic perspective, we usually model at a watershed basin or watershed level. So I was wondering, like usually we have a statistical downscaling where we usually correct for the mean rainfalls. So do you think in such kind of statistical downscaling, the extreme values of projected climates are lost? Do you think like mean bias correction, such techniques usually suppresses the extremes, or should we have some other techniques that will preserve the extreme values?
Actually, for this and the codex runs and all, we don't go for a bias correction. We will use what we will do. We generally do a downscaling. So we use the CMIP6 data, and we use that CMIP6 data to force the regional model. That is the way we do. But if you really want to have regional assessment, it may be better like you do the first correct the bias, because model always have the bias. Regionally, SPC particular regions, it will have a bias. So first you correct for the bias, then you look for the changes in the extremes. That may be the better way.
Okay.
Anybody else? Yeah, if there are nobody else, we will go back. We will go back to Shama for vote of thanks. Meanwhile, I just want to inform you that the next lecture, July month, there will be another lecture by Dr. Surendran of CWRDM on impact of climate change on agriculture in Kerala. So just to say, I'm going back to Shama. Shama?
Okay, sir. I'm delighted to submit a vote of gratitude on behalf of ICCS to today's keynote speaker, Dr. Swapna Panickal, scientist IITM, who took time out of her busy schedule and chose to be with us to offer this outstanding and thought-provoking speech on relevance of recent IPCC reports for India. I want to express my sincere gratitude to our director, Dr. D.S. Spicer, for his initiative in organizing this lecture and also for his constant guidance and support. I would also like to thank all my colleagues at ICCS for their support. My deep sense of appreciation and thanks to all the participants who chose to be with us today and attended the webinar with great enthusiasm and made it a successful event. Once again, I thank everyone for sparing their time. Thank you and have a nice day ahead.
Thank you, Swapna. It was a really interesting. And in fact, we had around 50 persons actually joining. That shows, a lot of students, and particularly, they were all remained till the end. It shows actually the interest for that subject, and you had presented nicely. So I'm sure people might be benefited out of your lecture. Thank you once again. Thank you.
Thank you. Yeah.
Thank you.
Okay, Kripalani sir, thank you.